We've covered circular patterns and mirroring with the aluminum extrusions. Let's cover linear patterns in this video. So we'll start off by creating a sketch on our top XZ plane and make a rectangle. In fact, I'll go with rectangle by center. We'll add a horizontal on this line. We'll give this dimension of 6 by 4. And after that, we can deactivate the sketch. And I'll give this an extrusion dimension of 0.25. Let's put a hex pattern on this, right? We want all the little bits of soap to fall through the tray and not make that weird swampy soap scum stuff. So I will create a hexagon, apply, we'll make sure that the top is constrained horizontal. We'll take the center of our hexagon, make it 0.05, but I'll put a negative sign so it jumps to the other side. And same here, 0.05. That should position the center adequately, and our degree of freedom really is going to be this size now. So from top to bottom, I'll give this 0.75. I'll deactivate and run an extrude cut. I'll simply say through all, since that's what we want. From here, I wanted to define a specific and particular angle. And so to do that, I'll grab a new plane. And I'll select my YZ plane. And then I'll also select, and we can do this from the tree, my Y axis. And now I can specify a particular angle. Let's try -60. Yeah, right there. That's perfect. Next, I'll grab an axis, and that will define a good single direction. From here and to my new plane, we'll apply. And now I have this diagonal axis that is running through. And I can utilize now linear patterns. Linear patterns, like circular patterns, when I click here, is something that I can take a feature and pattern it multiple times. So I'll select this cut to pattern. I'll select my path as my axis. And we'll say 0.8. Just like that. Next, I'll probably want to pattern this to be a whole complete hexagon mesh. So I'll choose a linear pattern. And notice it's pre-selected my feature pattern, which I've wanted. And I'll also select my original one as well. For a linear path, I'll choose this edge here. And then maybe I can give this a different dimension. 1.386. Of course, we can make this however we'd wish. I'll change the direction. And as you can tell, every time I click an instance, I get another pattern. But I can do it in not just one direction, but multiple. So I'll select another direction, and I can choose a linear path going up and down here. For my spacing, I'll go with 0.8. And then I can increase my instances and change my direction, and we have a total hex pattern. Next, I can even change my direction to go down this interesting diagonal path if I'd like, and I can get this cool diagonal hexagon pattern since these hexagons work off of 60 degrees, which is kind of cool and interesting, but of course my real intent is for it to be completely meshed. But fun things you can do with patterns just like that. Maybe I can finish off my dish by creating an outer boundary. So here's a cool sketch technique that you can do, right? I can project my previous sketch number 1 in with maintained association, and I'll bring that in. I'll bring that in as a sketch figure. And then I can make another rectangle, right, and dimension it appropriately. But of course, I know I want to have consistent wall thickness and whatnot, so I can choose offset right here. And what offset does is I can select all of this, and then I can give it a distance. I'll go with 0.125 perhaps. And it gives me a consistent offset from one sketch to another. And so the workflow with offset is you can either leave it the way that it is here, and if you make any changes, you delete what's red and re-offset the whole thing, or you can fully define it currently as we sit here. So I can do that, right? I can say equal from here to here, and then I can give this a dimension there. And I can make sure that these lines are equal. And then I ask myself, well, where are we not fully defined? Right, and it's just going to be these guys over here. So we'll add in 0.125. And lastly, 0.125. Which probably negates the fact that I added the equal constraints. But, you know, we can fully constrain it. We'll extrude that up an inch. And we have a soap dish. And that's how we do it. Hope you're patterned out because we're covering new topics in the next video.